Okay, today we are going to be talking about type 1 compounds. Well, that's very nice, Mr. A, but what is a type 1 compound? A type 1 compound is a binary ionic compound. So by binary, you should know that's from your vocabulary. That means that we've got, say, binary ionic means that we've got one metal and one non-metal. So we're going to combine a metal and a non-metal and make it a compound. So that means, so here's a great idea. While I'm giving this kind of an intro, y'all need to get a pencil and paper, maybe make some notes, because I'm going to the trouble of teaching here. You probably need to go to the trouble of learning. All right. So we're going to be talking about binary ionic compounds, and these are type 1 compounds. All right. That means that it's a metal and a non-metal. Specifically, it is a metal from groups 1 and 2 and a non-metal, okay? Because we can have some others, but we'll talk about those later. All right, so we are going to be talking about writing formulas from the names of binary ionic compounds, and we are going to be talking about names to formulas for binary ionic compounds. Let's take this one step at a time, with the easiest step being first. So this is formulas to names for type 1 compounds, okay? Let me give you an example of a formula that we are going to write the name from. You might recognize that symbol as magnesium. That is a subscript, and that is the symbol for carbon. Now, without saying anything, without raising your hand, I just want you to think to yourself how you might say the name of that formula, okay? Now, I'm going to teach you the steps. Step 1, write the name of the cation. Well, I would, Mr. A, but I have no idea what a cation is. Well, cations have positive oxidation numbers. So let's see. Let's go back to my periodic table. And you should have a sheet somewhere in your notes where you have written the oxidation numbers across the top of the periodic table. In that table, you would have written the oxidation number for all group 1 elements as a +1. The oxidation number for all group 2 elements is a +2. The oxidation number for, I'm going to skip over here to group 7. The oxidation number for group 7 elements is a -1. The oxidation number for group 6 is a -2. And then let's see, group 5 would be a -3. Group 4, now that could be plus or -4, and group 3 is a +3. You should have had those written across the top of one of your do-it-yourself, make-it-at-home periodic tables, okay? So that's a reminder of what oxidation numbers are. So write the name of the cation. Cations are positive. You can remember because cats have paws, right? Cations are positive. So the cation here is magnesium. It has a positive oxidation number of +2, but all you need to do is to write the name of the metal. That would be magnesium. Okay? And then step 2 is write the name of the anion. The anion. Anions are the negative ion. So this is an ionic compound, so one of them has to be positive, one of them has to be negative. Carbon, in this case, is our non-metal. It is our anion, so we are just going to write carbon, but it doesn't sound right if we say magnesium carbon, so we say magnesium carbide. Magnesium carbide. So we add the IDE ending to the end. So Mg2C, the name of that formula is magnesium carbide. Now, that might have been a little bit harder for you, but I think you'll get the hang of it if we do another one and step through it quickly. Now, one more thing to point out. I want you to ignore subscripts when you say the name. So we didn't say magnesium 2 carbide. So when you say the name, you ignore the subscripts, okay? So let's do this again. With another example, CaBr2, okay? Without saying anything, without raising your hand, see if you can come up with the name of this. Okay? Then let's follow our steps and see if we get the same answer. Step 1, write the name of the cation. Well, in this case, it's calcium. And then you write the name of the anion, adding IDE to the end. And don't say the subscript. So it's calcium bromide, right? All right. Let's do one more. This time you guys do it at home for our famous formula. What is that? And everybody knows that is right? Yay, this is easy, Mr. A. Okay, well, let me tell you what, it gets harder. So that is formulas to names, and you guys you've already been doing this sort of like automatically in your head. I didn't have to give you a step-by-step process for that, did I? Because it just kind of rolls off your tongue because you guys are getting so awesome at chemistry. Well, now let's go the other way. Names to formulas for type 1 compounds, okay? So if I gave you, let me see, let me pick something here that you may or may not be familiar with. All right. Potassium fluoride. This is a name, and we're going to convert that to a formula, okay? So you might be thinking of what that name or what that formula might be right now. The first step is what we've just done, is write the name, okay? Now, what I want you to do, this is going to be, I'm giving you a strategy now, right? Oh, I love it when you give me strategies, Mr. A. It helps me solve the hardest problems if I know how to do it. Okay, step 2 is draw an upside down T-chart. So here is a T-chart, and it's upside down. All right, now notice I put the dividing line right between the two elements in this binary compound. Binary meaning 2. There's 2 elements involved here. All right, draw an upside down T-chart, and then I want you to write the symbols with their oxidation numbers. Okay, so the symbol for potassium is a K, and let's see, that is a group 1 element, so it's a 1+. All right, and then fluoride is just a name for fluorine when it's in the compound, right? So you're not going to find fluoride on the periodic table, but you will find fluorine. Fluorine is a 1-. Okay, so we wrote the symbols with their oxidation numbers. Now, step 4. Add as many symbols as necessary to zero the sum. Now, what do I mean by that? I want you to add up all the oxidation numbers on this side, and then I want you to add up all the oxidation on this side, and then I want you to sum these two sides together, and a positive 1 plus a negative 1 is equal to 0, right? All right, as necessary. Well, this was easy to do because the oxidation numbers already added up to equal 0. And this is what I called in class as a match made in heaven, right? Because we can take the positive ion of potassium and the negative ion of fluorine, and it just, when you write the formula, step 5, all you do is you write the formula with subscripts equal to the number of symbols. So I've only got 1 potassium symbol over here, and I've only got one fluorine symbol over here. Now, I don't write the subscripts of 1 and 1 because that's implied, right? It doesn't make any sense to write 0 because you actually have 1. It doesn't make any sense to write 1 because you know there's 1. You only write subscripts when there's more than 1. Okay. So let's leave our steps here and let's do one that's a little bit more complicated. This was a match made in heaven, so we didn't need to do much to that. But I'm laying the groundwork for the strategy, right? Okay. Let's take another one. Lithium oxide. Okay. You write the name, you draw an upside down T-chart, and then you write the symbols with the oxidation numbers. Okay. Lithium, Li, has got an oxidation number of 1 plus. Oxygen has an oxidation number of a 2 minus. Now, if you bring these two down, you can see that they're not going to equal 0. The strategy says add as many symbols as necessary to 0 the sum. Well, how am I going to get to 0? I've got a -2 over here and a +1 over here. So, oh, Mr. A, I know. Oh, Mr. A, I know. Add another lithium. Okay, so we're going to add another lithium. Just dot my I's, all right? And that gives me a 1 plus over here. So now a 1 plus and a 1 plus is a 2 plus. And look, ta-da! These are going to balance out to equal 0, right? So that's what we need to do. We added as many symbols as necessary in order to equal 0, right? Step 5, all we got to do is now write the formulas based on how many symbols we have. So we have 2 lithium symbols here, Li2, and we have 1 oxygen symbol here for O. So the formula for lithium oxide is Li2O. Okay? I think we're getting the hang of it. Let's do one that might be a little bit more challenging for you. Oh boy, Mr. A. Okay. Barium phosphide. I have never heard of such a thing, but it doesn't matter. We can look this stuff up on the periodic table. You write the name, do your upside down T-chart, and then we're going to write the symbols with their oxidation numbers. Barium is in group 2, so it's a 2 plus, and phosphorus, that has an oxidation number of a 3 minus. Phosphide, phosphorus has a 3 minus. Okay, so if I bring my total oxidation numbers down here to the bottom, I've got a 2 plus and a 3 minus. Well, not sure which one to add here, but I always say add one of the lowest that you have. Okay, so 2 is lower than 3, so let's add another barium. Okay, 2 plus. All right, so 2 plus and 2 plus now becomes 4 plus, right? And they're still not in balance because this is a 4 plus and a 3 minus. So, okay, so add one more, the one you have the least of, so I needed another phosphorus. Now that's a 3 minus, and a 3 minus and a 3 minus is going to equal a 6 minus, right? Mr. A, it's never going to come out. Look, this is a 4 and a 6, and it's just not going to work, darn it. And some of you are saying, ooh, Mr. A, add another barium. And now we have a 6 plus and a 6 minus. They balance, right? So now all it's left to do is step 5, write the formula. We've got 1, 2, 3 barium particles, and we got 2 phosphide particles. Ba3P2 is the formula for barium phosphide. Pretty cool, huh? Okay, I'm going to give you a chance to do this for yourself, and you'll be able to demonstrate it to me through a homework problem. First of all, there's one little thing I wanted to do. Whoa, isn't that cool? Hey, take a picture of that, Mr. A. I can do all kinds of tricks with my little magic whiteboard here. Okay, so I am going to go back to, I'm going to stop sharing. Wait a minute. First of all, any questions on the strategy? Nope, I don't hear any questions. Okay, so this is being recorded, so you'll be able to go back and review that strategy. I am going to give you a link to not only my recording of this, but I will give you a link to one of my favorite YouTube educators, Tyler DeWitt, who inspired me to set up my teaching station this way. So I think you'll see where I got all my good information from, and I hope that I've communicated some good information over to you. Okay, so there's going to be an assignment posted in the Google Classroom. It is going to be what I call a formative assessment. So I want you to fill out, it's basically a really short worksheet, 10 questions. There's going to be 5 names to formulas and 5 formulas to names. So you have to be able to go both ways. You'll demonstrate that to me. Please use the Kami app to edit the PDF directly. It was really, really hard reading some of your handwritings and then your photographs of your work, or it's not always a high resolution, and then sometimes you had it rotated, and I kind of had to turn my head this way in order to grade your stuff. So if you use that Kami app, you can annotate directly on the PDF. That means you can type, you can draw, you can highlight, and then you just click submit. It never hits paper, comes right into the Google Classroom. I can grade it directly from there, so it works out great. Please use the Kami app to do your formative assessment on today's lesson on names to formulas and formulas to names for type 1 ionic compounds. Okay? Any questions? Because I'm here for you. All right, I'm going to stop the recording.